So today we're going to push on with kind of the beginning of Unit 3, has to do with relations and functions. Now you know a lot about this. Today is not going to be a real big, lots of algebra. We're not doing a lot of algebraic manipulation. It's going to be more just some concepts, and you got to keep these straight in your head. So you got to really kind of focus on the concepts. Click everything closed, focus completely up here. So we're going to talk what is a relation and a function. Remind ourselves about the domains and the ranges of a relation, and we're going to look at some different representations of relations, and that's really it. Okay, but there's a lot of stuff there. So what is a relation? Well, first of all, a relation, all it is, it's just a way to relate inputs to outputs. That's it. We need some organized way to take input numbers and calculate output numbers, right? That's what the relation does. Normally we express, well, you've seen this before a lot of times when you deal with ordered pairs. When we have an ordered pair, we're inputting what, x or y values? Which one do we input? X values, and we calculate or output y values, right? Based on the equation, whatever y is equal to, right? Okay, so we can, what are some different ways we can express relations? Well, we could express them as a set of ordered pairs. We'll look at an example like that. We could look at, sometimes we use tables to express relations or to show the connections between inputs and outputs. We can use graphs, or we can use what's called a mapping, which you've seen, but you may not know what it's called. In general, what do we call the set of x values? And let's not be that specific. We don't need to limit ourselves to x values. Let's just call them inputs instead. What's the set of all possible input values for a relation called? It starts with a D. Domain. The domain, absolutely. So the domain are all the x values that we could plug into a function, right? All the ones that would work, that I could plug in. What's the set of output values, or more generally, the outputs called? What is it? The range, yeah, there you go. Okay, so the set of outputs is called the range. And this is not such a big deal, but a lot of times we're used to seeing relations with connected lines or curves when we look at the graphs. That's normal for us, and we call those continuous. But sometimes we'll see relations graphed where we just have distinct points, and we call those discrete relations. Okay? How about a function? A function is a special type of relation. All functions are relations, but not every relation is a function. Let's get rid of earbuds. I don't see any earbuds out there, please. So what does it take for a relation to be a function? It has to meet a set of criteria, or pass a test, we could say. The test for a function, or for a relation being a function, is this one. A relation is a function if each element of the domain is paired with exactly one element of the range. Okay, that's a way of saying it. Perhaps this is an easier way of saying the same thing. A function is just a relation where each input has exactly one output. Have you heard something like that before? In the past, maybe, for your function rule? Probably something similar to that, I bet. Think what that says now. A function, or a relation is a function if each input only has one output. That's the only rule. If we pass that test, then the relation graduates to become a function. Let's look at two examples of relations, one of which is a function and one of which is not, and see if we can figure out what's going on here. So how would we describe that relation there? What do those squiggly brackets mean? Set. So it's a set of some things. Show me with your fingers, how many things are in that set? Yep, 4 things. 4 things. 1, 2, 3, 4. What are each of those things that are in the set? I mean, okay, I mean, kind of, but when those mean something. When I have parentheses around two, what do we call that? Around ordered pairs, yeah. I have a set of 4 ordered pairs. Now, if I graph those ordered pairs, what would those look like on a graph? 4 what? Points. We'd have 4 points on the graph, right? But they're just ordered pairs, we could call them. I have 4 ordered pairs. Each of those ordered pairs represents an input and the corresponding output, right? Okay? That one is a function. Here's a similar set of 4 ordered pairs that is not a function. Why not? What's the problem? Which one? Ah, there's the problem. Yeah, look at this. If I input a 1 in this set, how many different outputs do I have? 2. That's a problem. That breaks the function, it fails the function test. For a relation to be a function, each input can only have 1 output. If I input a 1, I have either a 9 or a 12 as my outputs, too. That doesn't work. No, that's not true. We'll see some examples where that can still work and be a function, and we'll see why. Yeah, but each input can only have 1 output. The reverse direction is not necessary. We don't have to have another rule for that. Okay, so what's a quick way of scanning? When we see sets of ordered pairs like this, there's a real easy way. How did you see it so quick? What did you notice right away that said, oh, not a function? You had repeated values, didn't you? If you have repeated x values, then automatically you know that's not a function, right? Okay, Donovan, why don't you take that out for me? Thanks. Yeah, I don't want to see earbuds in here. During class, when I'm teaching, those need to be away. Okay, so now this evolves into a test for graphs that's really simple. Give me a 1 to 5 on how familiar you are with the vertical line test. Do you remember that from previous years? 5 meaning I perfectly remember it. 1 meaning I've never heard of the vertical line test. Where are we? Okay, we're running the gamut here. Let's remind ourselves. The vertical line test is just this. In order for the graph of a relation to represent a function, a vertical line cannot intersect the graph in more than one place. If I pass a vertical line across a graph and it intersects in more than one place at some point, then that graph is not a function. That's the vertical line test. So here's an example of a graph that would pass the vertical line test. That is a function. If I sweep a vertical line across that, it's never going to intersect it in more than one place. Agreed? Okay. Here's an example of a graph that's going to fail that. Okay, where does it fail? Right there. Look, there's a spot where it intersects in more than one place, and so it fails the vertical line test. That's not a function. Okay, give me thumbs on that. Does that make sense? Okay. Real quick, I'm going to give you a way to kind of keep some of this stuff straight. So everything in the left column means the same thing, essentially, right? X's, our inputs are normally X's, and the set of all inputs is the domain. Our outputs are normally Y's, and the set of all outputs is called the range, right? Now notice, here's a way to keep all these things straight. X's and Y's go together. Inputs and outputs are kind of, they're the sort of opposites in a way, but they go together, same idea. Domain and range go together. Notice that all the stuff that corresponds to inputs comes alphabetically before the corresponding things that correspond to outputs. X goes before Y alphabetically, I goes before O, D goes before R. So you can always keep all that stuff straight that way. Okay? Okay, true or false? That graph is a function. True, it is. A vertical line never intersects the red graph in more than one place, so it's true. True or false?
False.
False. There's an example, right? False. True or false? That discrete graph?
False.
False. You caught it. There's one spot clear over here, isn't there? Because of that, it's false. Okay, give me thumbs. All good? You got the vertical line test. All right. Okay, so now we're just going to play this game where we're just going to go through and I'm going to show you a variety of representations of a relation, and each time you're going to tell me the domain and the range, and you're going to give me a thumbs up or down on whether it's a function. So what's the domain of number 1? There you go. -1, 0, 4, and 6. It's just the set of all. Oh boy. Okay. Give me a second here. This dumb thing.